Today we are going to see about the construction feature of hysteresis, hysteresis motor. Hysteresis motor is a synchronous motor with uniform air gap and without DC excitation. It operates both in single and three-phase supply. The torque in hysteresis motor is produced due to the hysteresis and eddy current induced in the rotor by action of rotating flux of stator winding. The working of motor depends upon the working of continuously revolving magnetic flux. For the split operation, the stator winding of motor has two single-phase supply. The stator winding remains continuously connected to the single-phase supply both starting as well as running of the motor. The rotor of motor is made up of smooth chrome steel cylindrical and its no winding. It has high retentivity because of it's very difficult to change the magnetic polarity once they are caused by revolving flux of the motor. The rotor of hysteresis motor moves synchronously because the pole of the motor magnetically locks with the stator with its opposite polarities. Then the construction of stator of the hysteresis motor. The stator of hysteresis motor produces a rotating magnetic field and is almost similar to the stator of induction motor. Thus, the stator of the motor is connected either single-phase supply or a three-phase supply. The three-phase motor produces a uniform rotating field as compared to the single-phase supply. The stator winding of single-phase hysteresis motor is made up of permanent split-phase capacitor type or shaded pole type. The capacitor is used with axial winding in order to produce a uniform field. Then the rotor, the construction of rotor hysteresis motor. The rotor of hysteresis motor consists of core of aluminum or some of other non-magnetic material which carries a layer of special magnetic material. The outer layer has number of thin rings forming a laminated rotor. The rotor of the motor is smooth cylindrical and does not carry any windings. The ring is made up of hard chrome or cobalt steel having a large hysteresis loop. Then the operation of hysteresis motor. When the supply is given to the operator stator, the rotating magnetic field is produced. This magnetic field is magnetizes the rotor ring and induces the pole within it. Due to the hysteresis losses in the rotor, the induced rotor flux lags behind the rotating stator flux. The angle of del between the stator magnetic field B and the rotor magnetic field BR is the response for protection of torque. Thus, the value of coercive force and residual flux density of magnetic material should be large. The ideal material would have rectangular hysteresis loop as shown by loop 1 hysteresis loop figure. The stator magnetic field produces the eddy current in the rotor. As the result, they produce the own magnetic field. The eddy current loss given by the equation shown below. F2 equal to S into F1 tau E equal to BE by S into omega S. Therefore, TE equal to K dash into S, where K dash is equal to KE F1 squared B by omega S. Therefore, TH is equal to KH S into F1 B power 1 by 6. The torque is given by tau H is equal to KH F1 B1 1.6 by omega 6 constant. From this equation clear that the torque is proportional to the slip. So thereafter the speed of the rotor increases, the value of decreases. The speed of the motor reaches synchronous speed, the slip becomes zero and torque is almost zero. Thank you.